Hi, I'm Anthony Miller. It's a pleasure to present my good side, money side model. Unfortunately, I cannot attend the Austrian Economics Research Conference, which is really a pity, but I hope I can give you some idea what I'm talking about. The paper says novel way, but I use the oldest economics formula that exists. It goes back to David Hume in the 18th century and to Nicholas Copernicus in the 16th century, but it also has a modern version, and it was just in this past year when Evans and Thorpe provided an Austrian version of this equation. I use the good side, money side version. It actually goes back to a statement by Hayek. So please don't confound it with the good side, money side of the ISLM model. And so with a fixed money supply and a constant velocity, the relationship between prices and products forms a hyperbola and denotes the purchasing power of money. And on the right side, we have the output. Here is the model of macroeconomic liquidity. Here are some explanations. I have to do it quickly to have only a short presentation, but just to say here is an increase of the purchasing power of money as we move down the curve, which represents macroeconomic liquidity. The good side differentiates between a natural, cyclical, and absolute production frontier. So we have the absolute and natural production frontier independent of the price level, and the cyclical production frontier which connects the money side with the good sides. Here also some explanations for the details. Now this is the GSMS model. The components, we have the price level, we have the output on the horizontal axis, macroeconomic liquidity, natural production frontier, absolute production frontier, and the cyclical production frontier. And besides, there is also nominal GDP, the nominal national income. So we have quite a host of macroeconomic variables in the model present. Now to the dynamics of the model. G stands for growth rate, M for monetary mass, V for velocity, Q for output, and P for the inflation rate, for the price inflation rate. And we can have some transformation, and we isolate the price level, which is, or P is a change, and we have here our vertical axis, and here the components that make up the good side of the model in its details. Now we can use this model, and this is the innovation for some macroeconomic constellation. Here a selection of these macroeconomic constellation that we can model with the help of this approach. Productivity-led deflationary economic growth, monetary price inflation, hyperinflation, deflation, deflationary depression, stagflation, and inflationary boom. Now here is these constellations, deflationary depression, for example. Here we have the major variables, and here the direction that these variables take. For example, an upward to the right shift, or downward to the left shift, or downward shift, or no shift at all. Now, as to the analytics of the components, here the components that are inherent in the model that are depicted here. G for growth rates, here the price inflation rates, and here the constellations. And we can have a form of disposition of the different variables that make up a certain constellation as a, let's say, analytical grid or analysis grid of macroeconomic constellations. Business cycle analysis. Now here the business cycle modeled in this approach. We have here the starting point A, a monetary expansion moves the ML curve to the right, upward. No, we have this typical premise of the Austrian business cycle approach. No, and this moves us beyond the natural production frontier, and as we move along the cyclical production frontier, prices will rise, and when rational expectation that in, prices will rise even more. Though this point is not stable, we enter in an inflationary boom that reverts into a recession, and this recession has the tendency to go back to a deflationary depression. So we from the point D, we tend to move back to E. So without governmental intervention, we would find our new equilibrium back at F. But of course, monetary and fiscal policy will try to maintain point D or move us forward to the right. And with that, they tend to prolong the recession. The same thing, a similar thing can be said about inflation targeting. Now here we have this point A. Now let's assume that we have a situation where productivity gains happen. So we would move the cyclical production frontier downwards, and the natural production frontier would shift to the right, so the natural point would be B. And this move would be the natural path of growth, a deflationary economic expansion or deflationary economic growth. Yet deflation targeting, IT, wants to maintain a certain price level, and that would mean that they initiate, as we have said before, an inflationary boom as they would augment the macroeconomic liquidity, and we have a cycle as it was shown earlier in the slides before. Now, macroeconomic policy concepts. We can model nominal income or GDP targeting. One can model inflation targeting and Keynesian full employment output targeting. And here are the constellations, the points, and the variables that make up these various macroeconomic policy concepts. Now, just as to the point of Keynesian full employment targeting, where you actually want to have an increase of output and you initiate a monetary expansion, but this monetary expansion typically fails because this move does not affect here real output, but the impact goes into inflation. So one can quite interesting in a clear and very precise way model various concepts. Here, for example, the nominal income targeting, one can see that this would be the monetarist concept. The growth rate of the monetary base together with the monetary multiplier would be the monetary mass, the basic monetary aggregate, and this would be the targeting of the monetarist. And nominal income targeting is actually nothing more than the same as the monetarist, including the velocity. So then you have here nominal GDP in this respect. So there are many things you can do actually with this model. Well, here are the links to the papers that I have on this project, and I'm looking forward to your comments. Thank you very much. It's been a pleasure to make this presentation. Just one remark. There's also an extension of this model that we did not treat here. It's in here. So there's also the GSMS SS model, where the good side, money side model is combined with a neoclassical growth model, and also an interesting feature of the business cycle. Thanks again. Have a nice conference. I'm sorry that I cannot participate, but maybe you can launch this presentation for those that are interested in. Thank you very much.